Hello everyone, this is the 8th grade review sheet by topic. We're going to start with Station 1, Simplifying Expressions. Just remember, when you're simplifying expressions, you do not have to solve anything. It's not going to be like x equals 3 or anything like that. It's just going to be simplify. We're simplifying and we're just combining like terms. So when you see that word simplify, it does not mean to solve. All right, so we're just going to simply do distributive property. Distributive property is 4 times 2x is 8x. And then 4 times negative 8, that's what that is. 4 times negative 8 is negative 32. And that is your final answer. You don't have to do anything else. All right, so simplify, in other words, simplify, not solve. And here we go, distributive property. I'm going to grab my calculator. And I'm going to just bring it over here. And on your calculator, you see this negative 2/3. I'm going to press the fraction symbol. I'm going to press negative 2. It does not matter that the negative is on the top with the 2. As long as it's a negative fraction, negative 2/3 times x is negative 2/3 x. And then negative 2/3 times 3/5. So I'm going to press times. I'm going to press the fraction symbol again. And I'm just going to put 3 over 5. So that's negative 2/3 times 3 over 5. You press enter and you get negative 6 over 15. The arrow down means simp. So I'm going to press that simp and then press enter. And it's negative 2/5. And that's exactly what you put down. Right? That's it. You don't have to do anything else. That's simplified. To go down here, simplify the expression again. So we're just going to combine like terms. We have 4x and the negative 8x. 4 minus 8 is negative 4x. And then we have 2 minus 7. Put it in the calculator. Don't take it for granted that you know it. Just to make sure, 2 minus 7 is negative 5. This is your answer. It is 4x minus 5. When we're talking about simplifying this, again, simplify, we have a lot of students had trouble with this, but just remember a like term has the same variable, same letter, and exponent. So when you're taking a look at the left-hand side here, this is negative 3x squared. I'm going to scan this whole expression to see if there's another x squared. There is another x squared right here. So if you take negative 3 and you bring up your calculator, you put negative 3 plus 8 into the calculator, you get 5. So that means when you combine those terms, it's 5x squared. What I typically like to do is to cancel out when I'm combining like terms, and the terms that I combined already, I kind of cancel them out, and I go to the next term, 2 terms that we're going to combine. So the next terms that I'm going to combine is negative 5x and negative 7 over 2x. So I'm going to take my calculator, do negative 5, and then see this negative 5 minus 7 over 2. So minus, and I'm just going to put 7 over 2. Just like that. And it's 8.5. So if I press this double arrow, it'll tell me negative 8.5. It'll convert that from a mixed number to just a nice decimal that we could use. So we have negative 8.5, and that makes sense. Negative 8.5, and that's x. So I combine those two x's, and then the rest is just positive 2 minus 4, 2 minus 4, and that's negative 2. And that is your final answer. So you combined all those terms, the x squareds first, then followed by the x's, and then the constants. All right, simplify the expression below. Before I start with 9 over 5y, I'm just going to check to see if 9 divided by 5 comes out to be a nice decimal. It does. It's 1.8. So I am going to, anytime you want to convert to a decimal, you can. I think it's easier to actually convert that to a decimal right off the bat. If it wasn't a decimal that was a terminating decimal, like 1.8 is a terminating decimal, then I wouldn't have done that. I would have just went with the 9 over 5. You don't have to do this, but I think it's a lot easier if you do. Bring down the plus 2, and then I'm going to do distributive property. Negative 4, this is a negative 4 times y is negative 4y. And then negative 4 times a positive 3.8. Sorry, wrong calculator. Negative 4 times 3.8 would be negative 15.2. All right, so now looking at this and saying, okay, I have to combine like terms. Like terms are right here with the same variable and exponent in this case. So we have 1.8 minus 4. So I'm just going to put 1.8 minus 4 just to make sure that that equals negative 2.2. So that's negative 2.2y. And then I'm going to combine the 2 and the negative 15.2. So that's 2 minus 15.2. Just to make sure it's negative 13.2. And that is your answer. Simplified. It really looks like there's a lot of terms here, and there are. There's no equal sign, so this is just an expression that you have to combine. But anytime you see distributive property, anytime you see parentheses, we're going to do distributive property. So I'm just going to start all the way over here and rewrite everything that I see, bring everything down. 5.6x, and then negative 3 times positive x is negative 3x, and then negative times a negative, I know that's going to be positive, but I don't know what it's going to come out to be, so I'm just going to put negative 3 times a negative, and I'm going to press the fraction symbol, 7 over 3. And then I'm going to press enter, and it comes out nicely. It comes out to a positive 7. So now once I have all of these like terms all lined up, I'm going to go and say, okay, are there any x squareds? No. But there are some x's, and I'm going to highlight them. And there are a lot of x's. So I'm going to just combine all of those, and I'm going to combine them right in the calculator. So I'm just going to clear this out, and I'm going to go negative 5.3 minus, I'm reading it right here, minus 8.7 plus 5.6 minus 3. And that's all x, just remember. So I get a negative 11.4x. So the next thing that I'm going to do is I'm going to combine all the numbers without variables, and there's only 2. So I'm going to go negative 14 because that's what I'm reading, plus 7. And negative 14 plus 7 is a minus 7. Sorry. And that is my answer. That ends station 1. We're going to go on to station 2. Now we're going to solve. So now when, like in that first station where we just combine like terms and simplify, we're going to combine like terms, simplify, and solve. Right? So for this one is pretty straightforward. We are going to use distributive property. So I'm going to take my calculator and I'm just going to move it over here so you could see. And I'm going to press the fraction symbol, and it is 2 over 3 that we're distributing. And it's times 6. So that's 4. So I'm going to get 4x. And then I know this is going to be minus because 2 over 3, this is positive times a negative. So I'm going to press 2 over 3 again. Times negative 9. And then enter. And it's 6. Negative 6. It's 30. Equals 30. We're going to bring that down. Now we're just going to go ahead and solve. You add 6 on both sides because we're using inverse operations. The 6's cancel. You have 4x equals 36. You're dividing by 4. And you're going to get x equals, and then just make sure 36 divided by 4 is 9. X equals 9. Number 2, again, when you see parentheses, you do distributive property. 2x, 2 times x is 2x. 2 times 4 is 8. Just be careful when you're distributing here, because this is a negative 2, and you can see it right here. I'm just going to highlight it. That is a negative 2 that you're distributing, so it changes all the signs of everything inside the parentheses. This is a negative 2 times positive 2. So negative 2 times a positive 2 is a negative 4x. Negative 2 times positive 8 is a negative 16, equals negative 6. Don't start to move anything across the equal sign. Combine like terms on the left side first. So we're going to take the left side and we're going to make believe that this is the only side that exists. So we have 2x right here. You have negative 4x right here. We're going to combine that as 2 minus 4 is negative 2x. Then we're going to combine like terms over here. 8 and negative 16. 8 minus 16 is negative 8, and that all equals negative 6. We're going to bring that down. Now this is a two-step equation. You add 8 on both sides using inverse operation. And let me try that again. The 8's cancel. You have negative 2x equals 2. And then you divide by negative 2, and you get x equals negative 1. And that is your answer. For the third one, you're adding 5 on both sides. Again, using inverse operations, when you see subtraction, you're going to add to bring that number over to the other side of the equal sign. You have 24 over here. All right, there are 2 ways to do this. So I'm going to move this over here. This is one way. This is one. Method number 1 and method number 2. Just remember, pick one way and go with it. So for this way, a lot of the 8th graders, they like to divide by whatever's next to the P. And then this will cancel, and then you get P equals. So in your calculator, the way you would put this in is 24 divided by, and then you put your fraction 3/4. And then you'd get 32. That is your answer. For everybody else that likes to see a different method here, we're just going to use the reciprocal. Just remember, every time you have a fraction and you want the fraction to kind of like disappear or be equal to 1, you're multiplying by the reciprocal. So a reciprocal is to take the fraction and switch the numerator and denominator. You're flipping it, right? So if you did that to this, the reciprocal of 3/4 is 4/3. So you'd multiply by 4/3. What happens when you multiply a fraction by its reciprocal is that they cross cancel. So the 3's cancel with the 3's, the 4's cancel with the 4's. The P comes down. If you put this 24 times 4/3 into the calculator, you'll get 32. So either way is fine. I would prefer that you use the reciprocal every single time. So when you see a fraction, multiply by the reciprocal, but the other method is not wrong. All right, number 4. Again, we are taking a look at the left side. You're not going to bother with the equals 25 yet because, again, you have to combine like terms, and you should combine like terms before you move anything across the equal sign. So I'm going to grab my calculator again for this, and I'm going to clear it out. This is negative 6.1 plus 3.6. This is negative 2.5, and it's K. You bring down the plus 13, and you bring down the equal sign, or as always, and you bring down 25. Then you just go ahead and you subtract the 13 on both sides. Remember, you're using inverse operations to get that 13 across that equal sign. You get negative 2.5K equals 12. 25 minus 13 is 12. So after this is multiplication. You're going to divide. Negative 2.5. The reason why you're dividing is because you see this is multiplication. The opposite of multiplication is division. So we're going to get 12 divided by 2.5, and then you press enter. You get 4.8, and that is your final answer. Right? And that is it for, I thought that was the end, but it's not. So number 5. So it says, please, the equation shown below, please solve for the missing variable. We are going to solve. Remember, when there's x's on opposite sides of the equal sign, you have to get the smaller x over to the larger. It's not necessary that you get the smaller x over to the larger. We just like to do that because we like to work in the positive. So by subtracting the 5x, bringing the x's together, please don't bring the numbers together first. Bring the x's together first, and then bring the numbers together later. So we have this canceling, and then you have 5x plus 7 equals negative 2, just bringing everything down. Then you subtract 7 on both sides, and the 7's cancel. You get 5x equals negative 9. You divide by 5, divide by 5, and then you get x equals, and then we'll go and take the calculator, negative 9 divided by 5, and it should be negative 1.8. And that's your final answer. Number 6, determine the solution to the equation below. You see x's on both sides. People are doing this. plus 4, plus 4. Look, that doesn't get the x, that doesn't get your x's together, right? So if your x's are not together, you're not solving this. So adding 4 on both sides, that is not going to help. So we're going to get rid of that, and then we're going to say, okay, I have to bring the x's together. Usually you bring the smaller over to the larger. But in this case, I'm just going to go and subtract 8x on both sides, because if I subtract the 8x on both sides, they will be on the same side together of the equal sign. On the right side, you see all x's. On the left side, you see the constants. So we have 8 minus 3. So that's negative 5x. And now we're going to divide by negative 5, and we get x equals negative 4 divided by negative 5, and it is 0.8. So for number 7, again, please solve for the missing variable. I'm going to take that, I'm going to look at this 9 over 2, and I'm going to just go ahead and say, okay, can I break that down to a fraction, to a decimal that looks very nice? Yes, I can. I'm going to put I'm going to do 9 divided by 2, and I'm going to get 4.5. And I'm going to rewrite it. And then on this side, I'm just going to go ahead on the fly and do 3 times y, distributive property is 3y, and then 3 times 1.5, I'm just going to put that 3 times 1.5, and I'm going to get 4.5. And now that looks like an equation that I could absolutely solve. So remember, you have y's on, you have the variables on both sides of the equal sign. You're going to get them together using inverse operations. You cannot just combine them because they're not on the same side of the equal sign. So use inverse operations, and you get 1.5y plus 3 equals 4.5. Now you subtract 3, because again, you have to get the y alone now. Now that you got them together, you have to get that y alone. This cancels. You have 1.5y equals, and it's 1.5. 4.5 minus 3, 1.5. Divide by 1.5, divide by 1.5, y equals 1. All right, this is a nice long question. So I'm going to do some things here right off the bat and highlight just taking the left side. And I'm going to just highlight those 2 things because I have to, those are like terms. So I'm going to take this calculator and I'm going to go ahead and put negative 4.1 minus 7.4. That is negative 11.5x minus 12 equals 1.5x. And then here we go with distributive property. Negative 4 times x is negative 4x. And then negative 4 times negative 3 over 2. And let's see what that comes out to be. Hopefully it's nice. It is nice. So that's a positive 6. Now we have these 2 like terms on the right side. I'm looking on the right side. So I'm going to go negative 11.5x minus 12 equals, and this is now, I'm going to go 1.5 minus 4. And it's negative 2.5. x plus 6. At this point, I want to get the x's together, and so I'm going to just add 11.5x cancels, negative 12 equals, and then I'm going to grab my calculator because I don't know, negative 2.5 plus 11.5. And that is 9. And that's great. Nice whole number. And then we subtract 6 because we want to get that x alone. This cancels. You have 9x equals negative 18. Negative 12 minus 6 is negative 18. And you can divide by 9 on both sides using inverse operations. X equals negative 2. There's a lot of work for one single question, but that is it. So if you need to review, there it is. All right, station number 3. Real world problems. Self-assess when your group completes the station or when a timer goes off. Okay. All right, so we're going to read this. John paid Planet Burger Gym $70 membership fee plus $5 per training session. His total, very important for the month, is $180. Determine which equation could be used to determine how many training sessions he took for the month. So you're just going to have to, like during the exam, you're going to have to just pick the equation and not actually solve it. But let's go ahead and actually put the equation together. $70 membership fee. So I'm just going to put $70 plus, it says plus, $5 per training session. So I'm just going to put 5x equals, this total is 180. So if you see an equation like that, that's exactly the equation that you would pick. If you were asked to solve it, you would subtract 70 on both sides, and then this cancels. You have 5x equals 110. And then you divide by 5, x equals 22 training sessions. And that's it. Number 2, Great Kill Swim Club charges a yearly fee of $80 plus $15 per month. Hillside Swim Club, so that's Great Kill Swim Club, charges a yearly fee of $40 plus $20 a month. After how many months is the cost the same? So when you're talking about finding out when the cost is the same, and the same in math is an equal sign. So we're going to put Great Kills on one side, and we're going to put Hillside on the other. So Great Kills is going on the left. It's $80 plus $15 per month. The equal sign is in the middle because we have to find out how many months they cost the same. So 40, Hillside is 40 plus $20 per month. So this should look like an equation that you are used to solving. Remember, you have to get the m's together. You have to get the variables together. In this case, it's the m on either side. You subtract 15m on both sides. You get 80 equals 40 plus 5m. And then you subtract 40 on both sides. This cancels. You get 40 equals 5m. You divide by 5. And you get m equals 8. So how many months? 8 months. That they would cost the same, the swim clubs. All right. So one health club charges us $70. So this is one health club, number one. And another health club charges another fee. So I'm going to highlight one health club, $70 sign up fee, and $20 per month. Another health club charges $82 and $14 per month. For what number of months is the cost the same? So as soon as you see the same in math, it means equals. So I'm going to go into the left side and just say the one health club is over here is $70 sign up fee and $20 per month. And equals another health club is 82 plus 14x. And the x represents the months. So then I would try to get the x's together. You subtract the 14x on both sides. The 14x's cancel. You have 70 plus 6x equals 82. Minus 70 on both sides. This cancels. And you get 6x, well, equals 12. And then you divide by 6, going into the group discussion, and then x equals 2 months. That's it. All right, that's it. All right, the last station is determining the number of solutions an equation has. All right, so just remember, when you have the same x on both sides with different other numbers, so the same coefficient with different constants, that means it's no solution. When you have the same expression on both sides, the same x's, the same constants, the same everything on both sides, that means it's infinitely many. And when you have the x's different or just one x, that means there's one solution. All right, so let's get started and we'll go through and work these out. So anytime there, I wish everybody could just look at the equation and actually see if it's one solution, infinitely many solutions, or none. This should actually be changed to infinitely many. All right, it's infinitely, I don't know why I have the M there. So because many solutions could be just like 2 or 3 or 4 or 5 solutions, infinitely many means like every number. All right, so what I was saying is like, all right, when you look at an equation, you might see exactly what this means here and how many solutions it has right off the bat. But I'm going to go with like the method where I'm going to say, I don't know what it is yet. I'm going to solve each one down to where I could tell if it's one solution, infinitely many, or not. All right. So in this case right here, in every case, you're solving equations to get the ends together. The variables have to be together on one side. The ends are right here and here. You can't solve it right now because the ends are on opposite sides. So you subtract, getting the ends together, you subtract the ends. This cancels with this. Then you get -1 equals -1. The same on both sides. That means infinitely many solutions. And there it is, infinitely many solutions, because it's the same on both sides. So to start off here, well, I don't know what it's going to be, but I do know that I have to get the A's together. So I'm just going to add 3A on both sides. No, I'm not. Just realized not to do that. All right, so here we go. You see this A and this 4A, -4A? I'm going to combine that those like terms first. That is negative 3a. Right there. Right? You're combining like terms on the left side. There are no like terms to combine on the right side, so I'm just going to rewrite it. So at this point, I know what it is as far as the solutions go, but you might not. So you have to get the a's together. You add 3a on both sides, and this cancels, so there's 0 there. You have to put a placeholder. This cancels, so there's nothing there, but there's an 11 here. Does 0 equal 11? No, it's not. It does not equal. So that means there is no solution. When it's not equal on opposite ends like that, 0 does not equal 11, there is no solution. You could have stopped at negative 3a equals negative 3a plus 11. There's no way that negative 3a can equal negative 3a plus 11. So there's no solution for this one. Same coefficient with different constants. Same a's, same x's with different other numbers. All right, no solution. 0 does not equal 11. So let's go ahead and combine like terms on the left side right here before we do anything. So we have 3x plus 11 plus 2x. 3x plus 2x is 5x. So we have 5x plus 11. And now we have, see this 5x here? I'm just going to put that equal sign down, and I'm just going to put the 5x first. 7 plus 4 is 11. Same on both sides, infinitely many solutions. You could stop right there if you wanted to. You could subtract 5x on both sides if you wanted to, and you get 11 equals 11. Either way, it is infinitely many solutions. It's the same expression on both sides. And when I was like kind of just like saying, okay, maybe they wouldn't realize it. You subtract 5x on both sides, 11 equals 11. Same expression on both sides, infinitely many solutions. A lot of people have trouble with this one. For what value of p would make this equation have no solution? So that means no solution. You have to remember, no solution would mean, and you just look up here, no solution means same coefficient with different constants. So you have to have that. So I'm going to just put that here as a note. No solution would mean same coefficient, same x's, with different constants. So that means I have to have something in for p. I have to substitute some number in for p that would equal 5x. So if I put 2 here, 2 times x is 2x. That's not 5x. It has to be 5x. So obviously, what times x equals 5x? 5. So if I put 5 there, it would be no solution. Because 5 times x would be 5x minus 20. 5x minus 20 equals 5x plus 7. That's no solution. So p equals 5. No solution. For this one, a lot of people had trouble with this because of this negative. So I'm just going to rewrite y minus 4 equals, see this negative? I'm going to distribute negative times a positive. That's negative 4. Negative times a negative is positive y. So at this point, I still don't know I don't know what's going on. So I'm just going to subtract y on both sides, getting the y's together. After I get the y's together, I realize that they both cancel. And I get negative 4 equals negative 4. The same on both sides, same on both sides, same expression on both sides, infinitely many solutions. And that's basically it. You could take it down to negative 4 equals negative 4, or you could just leave it y minus 4 equals negative 4 plus y. A lot of people are saying, wait a minute, I don't understand because it doesn't look the same when it's y minus 4 equals negative 4 plus y. It is the same, because look, if you have positive y, there's positive y, here's positive y. If you have a negative 4, there's negative 4, there's negative 4. It's the same thing, but it's just switched. All right, so just don't forget, same expression on both sides. If you can't see it, then just get the x's together, get the variables together on one side. If they both cancel and you have the numbers that are equal to each other, that means it's infinitely many solutions. If numbers are not equal to each other, then it's no solution. All right, so one last one that we're just going to combine like terms. 9x plus 3x is 12x. And we're going to bring down the minus 10. 4 times 3 is 12x. And then 4 times x is 4x. So I'm going to combine like terms on that right side because I have two x's. That is 16x. So we minus 12x on both sides. Remember, get the x's together. And you get the x's canceling out there on the left side. And then you get 4x here. Divide by 4. Divide by 4. And then you have x equals negative 10 divided by 4. Negative 10 divided by 4 equals negative 2.5. And that is one solution. Even if it's 0, that means it's one solution. And that's it. You can have different x values. That's one solution. If you have one x value, like 2x plus 10 equals 20, that's going to be one solution. Solved it all the way down to the end. It's x equals negative 2.5. Even if, like I said before, even if it's x equals 0, that's not something that is no solution. 0 is a solution, right? So just be careful with that. All right, and I hope that helped, and thanks for watching.